This is Algebra 2, Chapter 1.3, exercises 13 through 19. I'm going to go over a few of these problems. This section has to do with graphical transformations of functions. 13, determine if each function is an even function, an odd function, or neither. And I'm not going to go over these problems A, B, and C. They are separate problems. I'm going to demonstrate graphically what an even function is. An even function is a function that reflects about the y-axis. So I'm drawing a parabola here. And this parabola, you may be able to see that it reflects about the y-axis. So this would be indicative of an even function. So that symmetry is reflective about the y-axis. Now, as far as odd symmetry, I'm going to draw this function here. Looks kind of like a cube root function. So just kind of crudely drawn. So there it is in red. Now, an odd function has rotational symmetry about the origin. So I'm going to rotate this about the origin. Here it is. So I've rotated 180 degrees, and it comes back to what it was originally. See there's the rotation. There's the original. Okay, so this has rotational symmetry. So I'm going to write that in as odd so we'll call that 180-degree rotational symmetry. So just see which ones these are, A, B, and C. I think one of them is going to be neither. Okay, 14. Determine whether each quadratic function is an even function. Answer yes or no. And again, we are back to this blue parabola I drew earlier. If the function has its vertex, if the quadratic function has its vertex along the y-axis, that means it's an even function. Okay, so that's a graphical explanation of what that is. And we can just look at, I'll just look at one of these. If we have this part A here, we have f of x equals 5x squared. What is that going to look like? Well, it's just going to be your parent quadratic function, but stretched by a factor of 5. So it's going to be kind of a skinny looking parabola like this. I know I'm not giving any kind of scale, but as you can see, this, because the vertex is along the y-axis, we have reflective symmetry about that y-axis. So we have an even function here. That's his answer, yes or no. Yes. So I invite the viewer to go ahead and do parts B, C, and D as well. Describe how to transform the graph of f of x equals x squared to obtain the graph of the related function g of x. Then draw the graph of g of x. Well, you may recall that your standard vertex form, the vertex form of a quadratic function is a times quantity. Now, they put in the chapter I have this 1 over b, and that's for horizontal stretch or compression, x plus, plus minus h squared plus k. So your A here in this instance is we have negative 1/3 replacing A. I'll put negative 1/3. And we have x plus 4, which is minus negative 4. Remember, x minus h squared. So what happens is that this x plus 4 moves the vertex to the left from the origin. So if we go 4 left, and really the way the graph paper is aligned gives us a hint of what is going on. And our vertex is right here where I've drawn it at negative 4, 0. And I'm going to draw in just a little dotted line representing our axis of symmetry. And for a standard y equals x squared parabola, we plug in 0, we get an output of 1. If we plug in 1, we get an output of 1. Oops, I said 0, output of 1. 0, output of 0. If we plug in 2, we get an output of 4. If we plug in 3, we get an output of 3 squared or 9, and so on. And so that's going to help us to draw this negative 1/3. If we multiply this 1 by negative 1/3, we get negative 1/3. If we multiply this 4 by negative 1/3, we get negative 4/3. If we multiply 9 by negative 1/3, we get negative 1/3 of 9 equals negative 3. So where these go is negative 1/3, 1 away, negative 4/3, 2 away, negative 3, 3 away. And then we have symmetry on the other side of the axis of symmetry. And we're going to go into, in chapter 5, a lot more detail about quadratic functions. So this is what the graph of this function is going to look like. And this is not an odd function because, or an even function because doesn't have symmetry about the y-axis. But if we moved it over, we see that it could, right? It's just been shifted over 4 to the left, 4 units to the left, and turned upside down by that negative sign in front of that 1/3. Okay, 17. Flying buttresses were used in the construction of cathedrals and other large stone buildings before the advent of more modern construction materials. And here we have a axis of symmetry for this parabola. Of course, it's only a partial parabola for this flying buttress. But if we say f of x equals x squared, then what is going to be happening here? Well, remember in the early one we had a vertex form is going to be a times quantity x minus h squared plus k. So what we do if we assume that f means squared here, what we are doing is we are shifting to the right. So that's going to be h minus, or x, that's going to be x minus 2, and we're squaring that, and then we have plus 12 plus 12, and then we have a negative sign out front because we have an upside down parabola. And then what is the fraction we have going here? Well, if we had 1, the regular thing would be like I showed in the earlier one. If we had xy 0, 0, 1, 1, 2, 2, 2, 4, 3, 9, 4, 16, 5, 5 squared is 25. So we're going a fraction here, and it looks like it's going to be negative 1/6, because that would be 25, that's 1/6 here, we're 1/6 of what's 1.5 times 6? 9, right? So yeah, so 1.5, 6, so 1/6, so negative 1/6 is what we're looking at here. So f of x equals negative 1/6. This quantity x minus 2 squared plus 12. And what is our domain? Our domain is going to be this right here. It's going to be the x values here. So in interval notation, we have 2, 8. So that's going to be this one here. And again, we're going to go into quite a bit more detail on quadratic functions in Chapter 5. So consider this chapter on transformations, looking at quadratic functions is an introduction to that. We'll come back to it later. Number 18, similar sort of thing. The vertex is going to be the coordinate pair h comma k. And we can see that k is going to be 3.5, h is going to be x plus 2, h minus 2. So it's going to be, h is going to be 4. So anyway, and then this is a very, very faint fraction here. You have to kind of work and figure out what that is. But it can be done. So I hope this has been helpful to you. Good luck, and thanks for viewing.